So this is the retaining plate, or the fixed plate that the blades pivot from, and you can see by the colour of this that I'm removing something from it, and in this case it's probably mostly oil haze and some dirt. This all needs to be clean. One side of this plate faces the diaphragm blades, and the other side of the plate faces the shutter blades. The shutter blades, of course, are it's more important that they move exceptionally freely, because otherwise you would get poor speeds. The diaphragm just needs to be able to move smoothly so you don't damage anything when you're changing your settings. The staining that you see on a plate like that, that's fingerprints. And that's because someone's just picked it up like this between finger and thumb. That could have happened at any time, right back from the time the shutter was first assembled to any time where the shutter's been serviced. That's quite normal, and although it's a bit regrettable, it usually doesn't cause any problems. It's more important if the face that faces the shutter blades had some serious corrosion on there, of roughness, which you can feel just by dragging a tip of a toothpick or something across the surface. You can tell if there's any serious roughness. Then you would need to polish that surface off, but generally speaking you don't need to. So these blades here I'm just looking at, and I'll find the right pair of tweezers. Each of these in turn will need to be cleaned. Now usually the diaphragm blades, I clean them with solvent. I don't polish them. The shutter blades, sometimes if they're marked, I polish them with metal polish, Brasso typically. But the diaphragm blades I don't. That's because you don't actually need them to move as freely and as fast as shutter blades. And secondly, they're quite easily damaged because they have the rivets on there. It's exceptionally easy to damage them accidentally with a polishing cloth while you're trying to clean them. Even cleaning them with cotton buds like this, you need to be very careful not to damage the blades. There's a lot of filth coming off here. Quite typically to do 9 or 10 blades here. Normally 2 or 3 cotton buds would clean them quite nicely. I can see going through a few more here. There's quite a bit of staining on those blades. It's nothing serious. Some of it's rub marks. It's where, because of the stiffness caused by the oil on those blades, the contact areas, some of the contact areas have been rubbing across each other, and you end up with a polish or a mark to the blade where that pressure's been. You can usually see patterns on the blades where they've been sitting in a fixed position for a long time, and the overlap of the blades has left a mark on there. Some of this might be, it could be to do with oils and contaminants of that sort. It may be that the oils have deteriorated to the extent that they're more like a lacquer now, in which case they don't come off with a solvent. Not the solvent I'm using. But these blades they're cleaning up well. At least they're not showing any signs of corrosion. You have to be quite careful when you're cleaning these things, and I might seem that look like I'm being a bit rough pressing down on them with my tweezers. You can be sure that that's only because I know exactly how much I can get away with, and I'm not really pressing very hard at all. The blades are not symmetrical. The little rivets on the blades that form the pivot points, at one end of the blade the rivet is closer to the centre line of the blade, and at the other end it's closer to the edge of the blade. They only go into the shutter in one way. If you put them all in the wrong way, you'll have incorrect aperture values. If you put some of them in the wrong way, you'll end up with a opening which is not circular. From time to time you do strike shutters where someone's had the diaphragm apart and misassembled it. I think I had one recently where somebody had all of the blades in the wrong way round. It still worked, it just wouldn't have been the correct aperture settings because of the position of the pivot points would mean that the blades were either more or less open than you would expect at the setting you'd chosen. Because of the marks on these blades, I don't expect that the diaphragm will look an awful lot different when I've finished than before I started. So we won't have that business of the blades distorting and bending up. The marks on these blades, a lot of those they're a permanent feature now. They could be polished away, but as I say, that's a very fraught business. Just as I was about to tell you, I had my blades all lined up neatly, ready for reassembly. The camera stopped, must have reached the file size limit there, must have been talking for ages. Start reassembling this now. Now the blades, I've got them all lined up so that they're correctly oriented so I can pick them up easily. Now the end that I'm dropping into this plate, there where the rivets are closer to the centre line of the blade. And these blades aren't lying dead flat, as I suspected would be the case, which may mean it's fun getting this all together. It's not the worst example I've seen. When you get this far around the plate, there are no more exposed holes. You've got to start pulling the earlier blades back out of the way. Now one of those blades felt to me like it popped out of position there. I could have done without. I think we've got 10 blades here. This is a much easier job when the shutter's only got 5 blades. And some lenses can have ridiculous numbers of blades. Even worse. Okay, so I've got all the blades in place. Now I've got to swing these blades back over the top there without disturbing anything. I'll take another toothpick to help me manipulate things. So I'll hold this blade down, lift these blades over. Oh no. At least one blade is out of position. It may or may not fall back into position as I reassemble things. Okay, so we've got that in place. I'll get this ring in place. I'll know where that has to go. I'm checking that the pivots all come up through the plate. As you can see, these two do not, which suggests that those blades are out of position. Here's one of them. Of course, here I'm only manipulating the top part of the blade. The bottom piece could have fallen out of its hole. I won't know. So at least I've got those in position. And I'll put the case on. I know which way round this goes. Like that. I'll flip my jig upside down, remove the outside piece, pop it underneath to support this. Line up my 3 holes, get the screws, fixing screws run through. Run that down very lightly. You don't do the screws up tight at this stage, because if this blade is not correctly located, you could damage something if you screw that plate down hard on the blade. I can see one blade's out of position because I can see its pivot point miles away from where it should be. Get that screw down there slightly. Right, here you can see the pivot points are all sitting in their sockets there until you get to this one. There's a pivot out of position here, and there's two out of position there, so I've got 3 blades out of position. See if I can draw that across. That's okay, that one's in. I'm just going to tighten this screw lightly. This blade certainly needs to be over here somewhere. Now there's its mate, that's just about going to drop in position there. This one here. Do that screw up a little bit to keep that one in place. Slacken this one off slightly. And push that blade across. And just about pick up that pivot point. And it's aligned. It's in its, all the pivots are correctly placed. I'll run the 3 screws up lightly. And if nothing has come disconnected from the moving plate, we'll get a circular opening there. And that's nice and smooth. There's no drag on that at all. That's good. Well, that went well. I'll do those 3 screws up tight now. And check again. That's good. And I can put back the settings lever now, the diaphragm settings, so I'll do that. I'll clean this. You can see that there's a fair bit of dirt came off that. There's it's oil and grease and the like. That's very dirty. That's good. And I'm just looking at the state of this plate. As I say, some distortion there is desirable to provide a bit of friction so that settings are not easily lost. Too much friction, of course, is not desirable. It doesn't feel right. Alright, I'll take a bit of molybdenum paste and just rub it around that top surface and the inner surface, and let's get this in position. It's around the wrong way and around that way. And see if I can get my 2 screws in position. One. That's the other. So I'll support that on the edge of the wooden block. Do that screw up tight. And it's mate over there. That doesn't look like that went in all the way. Support that. Tighten that up. That's good. Alright, so there's a controlled drag to that now, but those blades, when we started, they were distorting. They were quite badly distorting. They're not now. They're just moving freely. That's very good. So that's a good result, and that's the shutter case dealt to. So I can turn my attention to the mechanism plate and cleaning this up. Well, given the state of that and the general dusty and dirty look of that retard gear train, I will focus my attention on making that retard gear train cleaned and running smoothly first. I'm just taking the filth off that top surface. That'll do nothing for the way it works, but it'll make me feel better. Run some naphtha into that. Work the action. Now, if there's any congealed oil or dried up lubricants in there, this will tend to loosen it up and the naphtha will wash it away. And then always take the air and blow away your solvent, because when you're blowing away the solvent, you're also blowing away the contaminants that the solvent has picked up. If you just leave the solvent to evaporate, it will evaporate and leave the contaminants back exactly where they were. That's good. That's moving nice and freely now. And that I'll lubricate with a bit of graphite powder before I'm done, but basically that retard gear train's moving exactly as it should. And the mechanism plate, I need to clean all round the centre here where the main lever runs. That's the round ring here with this main dry spring is called the main lever. Where that runs round here, I want all of that old rubbish off there. And with the retard gear train, normally I hold back the pallets, swing the arm and release the pallets, and that's so I can, what that achieves is it winds up the spring in here so the spring's not in the way, and it means I can take a cotton bud round and clean that internal surface there without damaging the hairspring. The hairspring is visible here, and if that gets damaged, the retard gear train won't move in and out correctly. And your big problem with the retard gear train, if it didn't move freely in and out, is that when you set, you'd end up with all your speeds being the same. They'd be somewhere at the high end of the range. You wouldn't be able to get the slow speeds to work correctly because the arm would not move across freely when you would cock the shutter so that it engaged correctly with the speed settings cam. So I'll clean all this surface. Now there was one area here that looked like had corrosion or something on it. Let's have a poke at that. I think it probably was corrosion. It was probably from a drop of some moisture have got in there at some stage. It's not significant and it's not in the way of anything, so we can ignore that. Making sure any cotton fibres are gone. That's good, all the surfaces look clean. Pop that to one side. Let's look at the blade actuating ring. Looking at the state of this, normally there's not much to go wrong with these. There's a bit of staining here, but I don't think it's anything significant. It's nothing that'll come away. It's okay. We can pop that into place. It only goes in one position. And the retainer plate, I'll clean that. As you can see, you go through an enormous number of cotton buds or Q-tips doing this job. I think I get packets of 240, and I usually buy mine by 10 packets at a time. And I'm down at the supermarket again before you know it, getting more. I'm just looking at the state of this retainer plate. Just checking the surface is smooth. It's a little bit stained, but that's not significant. If there was crusty looking corrosion there, that would be significant, but minor staining like that is certainly not. This can go back in place. There's a little rivet on there that serves to locate that, so it can only go in one position. Now I've got 3 screws hold the retainer in place, 2 short ones and 1 long one. And if you mix them up, things won't work right. So take note of where they come from. Sometimes you'll find shutters where people have put little marks on them, scratched a mark in to remind them of where something is aligned. That's certainly a handy trick as long as it doesn't create a problem of its own. That's good, that's all moving very smoothly. And that is moved by this lever, which needs to be cleaned. Because it's got quite a broad flat surface there, if there's any old grease or rubbish on there, that will certainly affect how smoothly that will swing across. I'll just put a bit of molybdenum paste on there, just a wipe. And this is its return spring, which I can hook into place and check the action. That's nice and snappy, that's good. This mechanism plate I want to lubricate with some graphite powder next, especially the retard gear train and the blade actuating ring, and then blow away all loose graphite powder. You don't want loose graphite powder floating around in a shutter. It has a nasty tendency to settle on the inside surfaces of the lens, and it looks like tiny silver sparkles, and that would degrade your image quality, so you don't want that. So any graphite powder, it's worked in and then it's all blown away. What's left behind in there is basically going to stay there, and that would be microscopic particles compared to the powder you're flicking in there. Okay, so that's my next task, is graphite powder.